Hello dear students. So welcome to new math session. So today's objectives are we are going to recapitulate the Heron's formula, and then we are going to compute the area of a quadrilateral using Heron's formula. Let us now look into the Heron's formula. So according to which we have area of any triangle is given by square root of s into s minus a into s minus b into s minus c, where a, b and c are the sides of the triangle and s is the semi-perimeter. That is, s is given by a plus b plus c divided by 2. Now let us move on to a problem. So here we have a park in the shape of a quadrilateral ABCD has angle C equals to 90 degree, AB equals to 9 meter, BC equals to 12 meter, CD equals to 5 meter, and AD equals to 8 meter. So how much area does it occupy? So that means we have to find the area of a quadrilateral ABCD where one of the angle is given, which is 90 degree, and the four sides are given. Now here, uh, first we have to look at the unit also. Since all the units are same, that means all the lengths are in meters, so there is no problem with the unit. Now let us draw a quadrilateral. So let us take A, B, C and D with D be its vertices. And here angle C is equals to 90 degree. It's given. So let us write it down simultaneously. So it's given. First one, angle C is equals to 90 degree. Then AB is equals to 9 meter. Then BC is equals to 12 meter. And CD equals to 5 meter. And AD equals to 8 meter. So now we have this quadrilateral. So we need to find the area of this given quadrilateral ABCD, where one of the angle and its the length of the four sides are given. So in order to find the area of this quadrilateral, we are going to construct its diagonal, and we are going to split this quadrilateral into two triangles. Now for the timing, you can pause the video and you can think that which diagonals to construct. So for now, I'm going to join BD, because when we join BD, we are going to get one of the triangle as right angle triangle. Clearly you can see that triangle BCD is a right angle triangle with 90 degree, and we get another triangle which is A, B and D. So now in order to find the area of these two triangles, first we need to find the length of the diagonal BD. So this is our triangle BCD, the lower part, and we can see that triangle BCD is a right angle triangle. Now we get BD square equals to BC square plus CD square by Pythagoras theorem. Square of the hypotenuse is equals to sum of the square of other two sides. Here BD is the hypotenuse, BC is the base, and CD is the perpendicular. So now let us substitute the corresponding values. So which implies that BD square is equals to 12 square plus 5 square, and further which implies that 12 square is 144 and 5 square is 25, and which implies that BD square is equals to 169. This implies that BD equals to root over 169, and we know that 169 can be split up into 13 into 13. So therefore, BD is equals to 13 meter. So here we have this quadrilateral. So now area of this quadrilateral will be given by sum of the areas of two triangles, that is triangle BCD and triangle ABD. So let this be equation number 1. Now let us compute the area of this triangle separately. So since triangle BCD is a right angle triangle, let us use the formula half into base into height. So therefore, we get area of the triangle BCD equals to half into BC into CD, where BC is the base and perpendicular is CD. Now, if we put the corresponding values, then we get this is equals to half into BC is 12 meter and CD is 5 meter. So now we can cancel this 2 and 12. So that will give us 6 into 5, and that is equals to 30. So therefore, area of the triangle BCD is equals to 30 meters square. Now we have to find the area of triangle ABD. So let us now find area of the triangle ABD. For triangle ABD, it's all the sides are given, where AB is equals to 9 meter, AD equals to 8 meter, and BD we got it 13 meter. So let A be 13, B be 9, and small c be 8. Now here we are going to apply Heron's formula. So next step is we need to find its semi-perimeter. So that is S, and which will be given by A plus B plus C divided by 2. Now if we put the corresponding values of A, B, C, we'll get S equals to 13 plus 9 plus 8 whole divided by 2. Now this implies that S is equals to 30 divided by 2, and we get 30 by 2 equals to 15. So therefore the semi-perimeter is 15 meter. Now area of the triangle ABD will be given by root over S into S minus A into S minus B into S minus C by using Heron's formula. So if we put the corresponding values of S, A, B and C, we get area of the triangle ABD equals to root over 15 into 15 minus 13 into 15 minus 9 into 15 minus 8. Now let us solve this one. So this will be equals to root over 15 into 15 minus 13, 2, 15 minus 9 is 6, and 15 minus 8 is 7. So let us split 15 and 6 to its prime factors, and that will give us 3 into 5 into 2 into 2 into 3 into 7. Now let's pair up the numbers. So we'll get the pair of factor 2. Okay, we have one more pair of 3. So now this will be equals to 3 into 2 and under root of 5 into 7. Now which is equals to 6 into root over 35. Now we have to find the square root of 35. Now since 35 is not a perfect square number, so we cannot find its square root by prime factorization method or repeated subtraction method. So that's why we have to go with long division method. So here you must have done this in your junior grades. So let us quickly go through it. So we have 35. Now we'll give decimal point and we'll give 6 zeros. After that we are going to put bar above these numbers from the right side. So we'll pair up the numbers. So we'll get pair of 2 zeros, another 2 0, another 20, and we got this 35. So now after that we'll put a bar like this. Now we'll start with the leftmost number, which is 35, and here we are going to use squares numbers only. So 2 into 2 will give us 4, which is very much less than 35. 3 into 3 is 9, which is again less than 35. Then 4 into 4 is 16. 5 into 5 is 25. Then 6 into 6 is 36, which is greater than 35. So we'll go with 5. So 5 into 5 will give us 25. Now if you subtract, we'll get 10. Now after this, we have to double the divisor, and here the divisor is 5, so we are going to add 5. That will give us 10. Now next we have to bring down to zeros, but before that there lies a decimal point, so that's why first we put a decimal point. Now we'll bring down these zeros, and that will give us 1000. So now this will be go by 9 times, so then 109 into 9 will give us 981, and if we subtract, this will give us 19. Now here on the divisor side, before in the first step I said that it will get double, but here if the divisor is more than two digit number, then we have to double the only number which is present at the unit place, not all the numbers. So that's why we are going to double 9 only. So that's how we'll get plus 9, and that will give us 118. Then we'll bring these two zeros down, that will give us 1900. Now it will goes by 1 times, so 1 times will give us 1181. If you subtract it, we'll get 719. So now again similarly we are going to double the unit digit, so that will give us 1182. Then we'll bring this two zeros down, so now 71,900. Now it will goes by 6 times, so then this will give us 944. Now we are going to stop it here because it will goes on. So here if it goes on like this, then we are going to consider till 3 digit after the decimal point. So now we are going to substitute it here, so we'll get 6 into 5.916, so which will give us 35.496. So therefore area of the triangle ABD is equals to 35.496 meters square. So now from equation 1 we have this area of the quadrilateral ABCD equals to area of triangle BCD plus area of triangle ABD. Now we already got the area of triangle BCD and area of triangle ABD separately, so let us just substitute it here. So this will give us area of the quadrilateral ABCD equals to 30 plus 35.496, which is equals to 65.496. So therefore area of the required quadrilateral ABCD is 65.469 meters square, or if you round it up, then we can simply write 65.5 meters square. So it is better to write with 3 digit after the decimal point. So let us do this much for today. Now this is the assignment based on today's session. So you have to find the area of a quadrilateral ABCD in which AB is equals to 3 centimeter, BC 4 centimeter, CD 4 centimeter, DA 5 centimeter, and AC equals to 5 centimeter. So here all the sides and I think one of the diagonal is given to you. So you can approach it in a similar way. So thank you all. Stay alert, stay home, and stay safe. See you in the next session.